When you hear the word drought, what comes to mind? Probably cracked earth, right? Maybe an empty riverbed. But here's the thing. That's the end of the story. The real story, how a drought actually starts and unfolds, is way more complex. And honestly, it's pretty fascinating.
So let's just get right to it. What really is a drought? I mean, is it just a couple of weeks with no rain? A really hot summer? Or is there something, much deeper going on with our planet's systems?
Okay, so here's the absolute key thing to grasp. A drought? It's not a single event. It's a process. A really slow-moving hazard that builds up over time. It's got a beginning, a middle, and an end. And it's all driven by the super complex dance of our planet's water cycle. And you know what? That story always kicks off in the exact same place, way up high, in the atmosphere. So the very first sign of trouble, it's not on the ground at all. It's actually in the sky. This is what scientists call a meteorological drought. It's basically the official term for when you get way less rain than you normally would over a certain period. Think of it like the starting pistol that sets everything else in motion. So why the dry skies? Well, a lot of the time, the culprit is this stubborn high-pressure system. It acts like a giant, invisible lid on the atmosphere, and it just stops clouds from forming and rain from falling. It literally shoves all that moisture somewhere else. Okay, check out this number, 30 degrees. This is so cool. Around 30 degrees latitude, both north and south of the equator, air from way up high is constantly sinking down. And as it sinks, it gets warmer and just kills any chance of clouds forming. This is not a coincidence. It's the reason so many of the world's biggest deserts are right on these lines. It's like a built-in feature of how our planet's atmosphere works.
But look, local weather is only one piece of the puzzle. To really get what's going on with drought, we've got to zoom way out. We need to look at these enormous climate patterns that are kind of like the planet's hidden conductors, directing the weather across entire continents. And the biggest, most famous conductor of all, that's ENSO. It stands for the El Niño Southern Oscillation. Now, what it is a recurring pattern of sea temperature changes in the tropical Pacific. But its effects? Oh man, they ripple out across the whole globe. It can ramp up drought in some places while bringing massive floods to others.
So ENSO has these two famous moods, if you will, El Niño and La Niña. During an El Niño, places like Australia and parts of Africa, they face a way higher risk of drought. But then, during a La Niña, the whole script just flips. Suddenly, it's parts of South America that can get dangerously dry. It's like a global seesaw of wet and dry conditions. And get this, it's not something that happens every year like clockwork. ENSO operates on this really irregular cycle, somewhere between 2 and 7 years. And that unpredictability, that's exactly why drought risk can change so dramatically from one year to the next. It makes long-term forecasting a huge, huge challenge.
Okay, so what happens when one of those meteorological droughts just hangs around? Well, that's when the first domino falls. That initial lack of rain kicks off a chain reaction that really deepens the crisis, and it starts to have impacts we can actually see and feel right here on the ground.
Yeah, this lays it out perfectly. See how it works? It starts up in the atmosphere. Then it hits our water systems, our rivers and lakes. And finally, it hits our land and our food supply. It's a true cascade, where each step triggers the next one.
So stage 2 is called hydrological drought. This is the point where that lack of rain really starts to show up, You see it in falling river levels, lake shores that are suddenly way bigger, and even our underground water supplies start to shrink. The problem has officially moved from the sky into our water system.
And to understand this, you need to know about something called base flow. It's a really critical idea. Base flow is the water that slowly seeps out of the ground and into rivers. It's what keeps them flowing even when it hasn't rained for a while. It's basically the river's hidden life support.
I love this analogy. Think of all that groundwater as a water savings account for our rivers. Now, during a hydrological drought, the river isn't getting any more deposits from rain. So what does it do? It starts making heavy withdrawals from that savings account, and it drains it faster and faster.
And once that savings account starts running low, well, that's when we hit stage 3, agricultural drought. At this point, there just isn't enough moisture left in the soil for crops to grow. And this is where drought stops being just an environmental problem and becomes something that directly threatens our food.
And yeah, in the most extreme cases, this can lead to famine. This quote here really hits home.
It says that even when you've got all these other social and economic problems going on, the physical root cause of a famine is often this long, slow, relentless breakdown of the water cycle that we've been talking about. So, okay, we've established this is a natural cycle. But what happens when we throw a wrench in the works, a new, modern variable? What does all this mean now, with our global climate changing?
Well, the connection is pretty straightforward, and it's direct. A warmer world is, simply put, a thirstier world. Higher temperatures don't just mean worse heat waves, they actually pour fuel on the fire of the entire drought process.
This chart explains it perfectly. There's a sciencey term for it, evapotranspiration, but it's basically just all the water that evaporates from the soil and gets breathed out by plants back into the air. And as temperatures go up, that rate of water loss absolutely skyrockets. So think about it. Even if you get the same amount of rain, in a warmer year, less of that water actually sticks around. The whole system just becomes way less efficient. All right, so let's wrap this up. What are the big takeaways here? First and foremost, remember that drought is a cascading process, not just a dry spell. It starts in the atmosphere, then it moves to our water systems, and finally it impacts our food and land. We know that huge global patterns like ENSO are major drivers. And on top of all that, a warming climate's making the whole thing worse.
And all of this leaves us with one last really big question. Look, understanding this whole process from the sky down to the soil is absolutely essential. But just knowing about it, that's not enough. As these natural cycles start to shift and get more intense, we are all going to be faced with a massive challenge. How are we going to redraw our relationship with water?